Right, so here's a clock design I think came up with probably like 10 months ago. So this is a full mock-up. I'm using only the STL files rather than the original files I created with FreeCAD since just got a few issues with trying to get the file that actually has all the pieces together. Won't load on this computer, at least on Windows, because because I designed this when I was on the Linux partition, but enough of that. So basically, here's the design with a full mock-up. So as you can see, the faces actually extend above the case. So if you think about that as like the traditional case with black plastic that's inside the plastic clear case that has an insert above it. So as you can see, it's different. In this, I ended up not designing an insert because I designed this with the intention to maybe to be able to 3D print it one day if when I could afford it, which I don't know, that's still a long while off. But I won't go into why because that's irrelevant. But yeah, so when you go in, you notice that these extended bits are telling you what time is on the clock, with the big one being 12 o'clock, obviously. I mean, I think you could possibly get away with a custom insert only having 12 o'clock because, I think, well, I guess people are not as common with analog clocks these days. But anyway, so those are the pins, and here's the case. So those things there are to pull it apart because the two halves of the case are held together with friction, and I'll go find the case. Unfortunately, these didn't keep their file names when I opened them up. So I don't know where the case is. I think it's... There it is. So this is the inside, and both sides are the same, basically. I mean, I think it would be useful if they're on all four sides, but I think just trying to mirror it and rotation didn't really work well in FreeCAD. So yeah, here we go. As you can see, there's indentations here because there are actually two halves to each of the clock face, rather than it being like these ones being resting on a spring or whatever. I actually made it so that they're individual pieces, so that the two sides are individual. They fit onto opposite sides, and yeah, and actually there's a piece on the bottom and a piece on the top that's screwed together. Those are places for magnets, little ring magnets for the pins, which I'll go talk about the pins next for a slight adjustment I think should be made to these. And then that's the reason these are indented I'll explain after the pin. So yeah, that top part's for a magnet. It would be better to place the magnet there because I saw a video about the Shengshao clock and they actually have a ring magnet there, and then the ring that it's attracted to, well, it's just a piece of metal. It's not magnetic, so you don't need to worry about polarities. There's not too much to say about the pin other than about these, but yeah, the whole gears thing. So okay, that's part of the corner, which is in three parts, which is excessive in some way. I don't know. Okay, so this is the front part of the edge. So these are here to reduce friction because obviously it's resting on the clock, and that would create a lot of friction, and I guess you want to decrease the surface area. So this part goes on top, and this hole is for a screw because this, which is the bottom part, those are all for magnets, and this rests inside that little divot around the edges in the middle of the case. So that piece goes into there. And that screws into it. And of course, another thing about it is that obviously this is an extended part for the clock face. Okay, the corners. So that's the middle part of the gear. So your finger will be like, going in between those to turn it because it sticks out on the edges. And this piece you push into one side, and that piece you push into the other, and it holds with friction. Which I think adding a lot of surface area would help. I don't know, again, I don't know too much about the stuff. This is just sort of playing around, learning the software, since I did try doing 3x3s and stuff a bit, but obviously those seem a lot harder to do with cutting surfaces and stuff, and plus the software is it's harder to know what to do with it since not many people use FreeCAD designing twisty puzzles. Another thing I want to talk about, which would be helpful to have a file, is I think the things about clock that are hard is these gears. So these pieces need to interlock with these. Let me just... yeah, so obviously those have to interlock with gears, and I think that's perhaps where the most performance gains can be made, because I think magnetic pins mean that the pins aren't, you can get good pins that will be in the up position, and the only way to get them into the down position is to push your thumb, so you get a solid tactile thing with the pins with magnets that doesn't rely on whatever clicky stuff they did, because I know a lot of those cheaper Chinese clocks weren't so good. I think I do have a version that shows though that, yeah, I'm just remembering lots of little things because just sizes and stuff's complicated, because with those edge things, obviously they're on the inside of the clock, you need a gap between them, so it's like how much can you have? But yeah, it is intended, if printed, to be a fully magnetic clock. Obviously pins are normally magnetic, but you do get not so much on the turning, because with the turning that's a lot more difficult, and I actually realised you need so many magnets. You need 12, 24 total. It's just so much. Okay, so this sort of gives an idea of kind of gives an idea of these pieces and how they interlock with each other. I reckon it might not perform too well. It'd be useful if I could rotate this 12 degrees. Oh yeah, here we go. You can see that there's a lot of space there, which I'm not sure whether or not that's good or bad. I have a tendency to think bad. I think you want the pin there to have not too much tolerance. It's hard to tell because obviously you want a really tactile, thing, but I think adding magnets could help. But with magnets you need, 24 times 9 something? It's a lot. I remember I calculated it. It's a lot more than a 3x3. Just quickly get it. So yeah, obviously if you want one for each click, that's 12 magnets, and then 24 to attract them. Though you could get away with just, again, doing all of the pins. One side is magnetic. But yeah, so you have 24, and you need it on was it 18? Because there's two sides, which is 432. Though arguably on the corner clocks you could only have magnets on one side, but yeah. So yeah, I think that if you want a non-magnetic clock, you'd want much higher tolerances on this. But yeah, clocks are a lot more difficult to just think about. I mean, I don't really know much about 3x3s, but yeah. Yeah. Don't have much else to say. Just go back to this. So yeah, a lot of my thoughts when I was making it is I got the size wrong. So if you were to print out those STL files at full size, it's gigantic. It's like about, you want to print it about a third, and that's I think a touch bigger than current clocks. So yeah. But yeah, there's a lot of considerations you have to sort of think of, like how thick is this clock? And then with these pieces, obviously this has got a piece that's above it, that's screwing to a piece below it, that's holding it. What's the gap between those two? Because, yeah, I think that's more engineering type stuff, but yeah. This isn't really that unique, though, when you think about the mechanism, apart from the fact that rather than these pieces, these 5 pieces that aren't in the corners, resting on springs and being pushed up by the spring on both sides, there's no spring, and it's screwed up. There's a part beneath these that screw it on the other side of the clock, which, you might want to add a spring in there for tensioning, but yeah, I reckon that would definitely have an effect on performance. It's just, yeah, I definitely think having magnets for these is useful, because that could be a way to make this design, a lot better. Or at least it would perform a lot better probably with magnets than without. Again, I'd love to be able to 3D print this, it's just hard to know. I was sort of thinking, because I have seen a few videos that with twisty puzzles that was it SLS, the standard, like, 3D printing? I can't remember. Filament type isn't good. I think it's SLS is the one you want because it has like a box full of powder, and then the laser goes in layers, melting it together within a box rather than layering up, like drawing with filament and stuff, because that allows you not to have to worry about supports or anything since the rest of the material supports it. But yeah, it's a lot more industrial. I guess that, yeah. I do find it very hard to talk about this when all I have is the screen recording.